Okay, here's the solution to quiz number 1 for ECE 320 Digital Electronics. The first problem is adding resistors in series and parallel. So the trick is to notice that, well, first off, R is based upon your birth date. If you assume R is 1714 ohms, then these two in series add gives you 4714 ohms. These two in parallel add as resistors in parallel. And kind of showing off the HP calculator, what I kind of highly recommend. If I have 1714, push that on the stack and add 3000 to it. I know there's no equals button. This is all based on stacks. Once you get the stack set up, you can add them. Now in parallel with 2000, so the inverse of R1, 2000 inverse, add inverse. This is 1404 ohms. In series with 2500, in parallel with 1200, in parallel, the inverses add. In series with 800. So the, 800 add gives you 1717 ohms. So that's problem 1. For problem 2, same thing, just with complex values. Now with complex values, the HP, there's a complex button. So to do 1714 plus J 1800, you do 1714, enter 800, complex. Fix O2, I'm going to have fewer decimal points. So that's these two in series. In parallel with J1500, in parallel, the inverses add. So 0, enter 1500. There's J1500. Take its inverse. This together is 468 plus J871. In series with minus J2500. In series, they add. In parallel with J2000, 0, enter 2000. 1 over R2, inverses add, inverse. In series with 800. So that's the resistance of this network. Problem 3 is voltage nodes. Write the voltage node equations for this circuit. Start with the easy ones. I know that Vx is V2 minus V3. I know that 10Vx is V3 minus V4. That's my first two equations. I need a total of 4 equations plus Vx. I need 5 equations for 5 unknowns. That's 2 of them. Write 3 more. One equation is right here at V1, the current up, right, and down add to 0. That's your V1 minus V4 over 100 plus 2 plus V1 over 200 equals 0. At node V2, current left, down, and right equals 0. That's minus 2 plus V2 over 300 plus V2 minus V3 over 400. This node I can't write because I don't know that current. V4 I can't write because I don't know that current. I need one more equation. That's a supernode. Draw a closed path around your circuit. And what I need to do is, I haven't written anything for the 500 and 600 ohm resistor yet. Come up with a supernode that includes these two. This is one candidate. So the last equation would be V1 over 200 plus V2 over 300 plus V3 over 500 plus V4 over 600 equals 0. Gives me 5 equations, 5 unknowns. Next problem for current loops. Again, start with the easy ones. I know that I2 minus I1 is 2 amps. I know that Vx is I3 minus I1 times 400. And now I need 1, 2, 3, 4 plus 1. I need 5 equations, 5 unknowns. That's 2 of them. I need 3 more. Go around loop I3. These voltages add to 0. That's 300 I3 minus I2 plus 400 I3 minus I1 plus 500 I3 minus I4, and then back where I started, equals 0. Round loop I4. 500 I4 minus I3 plus 10Vx plus 600 I4. I'm back where I started. That's 4 equations. I need one more. The 200 ohm, 100 ohm hasn't appeared in my equations yet. So that's this big outer loop. 200 I2 plus 100 I1 plus 600 I4 equals 0. That's 5 equations, 5 unknowns. Note, I can't write the equation for I2 because I don't know what this voltage is. I can't write the loop equation for I1 because, again, I don't know what this voltage is. I need to do something else. That's where the super loop comes in. Problem 5. If you have this voltage, express this in terms of phasors. Give me the frequency and the phasor representation for x and y. To start with the frequency is 1 over the period. The period is 4 milliseconds, so the frequency is 1 over 4 milliseconds, 250 hertz. For x, the amplitude is 13 volts. That's this guy. And the phase shift. For cosine, the peak is at t equals 0. Here the peak is at 3.1 milliseconds, so I've got a 3.1 millisecond delay. That gives you a phase shift of 3.1 milliseconds out of 4 milliseconds. That's how much the phase shift is. That percentage of one cycle is 360 degrees, gives you minus 279 degrees, which is also plus 81 degrees. Angles are periodic in 360. Add or subtract 360, I get the same answer. For y, the peak is 9 volts. The delay is 1.8 milliseconds. Converting to degrees, that's 1.8 milliseconds out of a period. That percentage of one cycle, which is minus 162 degrees. So that should be the answer for problem 5. And number 6, this is a superposition problem. I've got a DC term and an AC term. The total answer will include both DC and AC. Here the frequency is based upon your birth date. So if I start out at DC the inductor doesn't matter, the capacitor doesn't matter, I just have a voltage divider. It's going to be 40 over 40 plus 15 times the input times 20 gives you the DC voltage, 14.55. For the AC term, convert the source to a phasor. This is 15 sine, so this is going to be 0 minus j 15. Again, 0 cosine, 15 sine. The inductor becomes j omega L, j 514. Capacitor, 1 over j omega C, minus j 116. Put these two in parallel, I get 35 minus j 12. And now do voltage division. It's this impedance divided by the total impedance times the input. Gives you the resistor capacitor over the total resistor capacitor plus inductor resistor times the input, 15 sine, gives you a complex number. And what that means is the real part is cosine minus j is sine. So this is the AC term. The total answer is DC plus AC. I'll add this term plus this term to get my total answer. And that's what you should have. So that's quiz number 1 for ECE 320 for spring 2022.